This question was asked in TIFR 2022, and it says that an observer moving with relativistic speed v away from the fixed plane mirror m, a line perpendicular to the mirror surface, it sends a light signal. This observer sends a light signal with wavelength lambda, and we need to answer what is the wavelength of the light reflected back to the observer. 4 options were given, so we will use the formula for Doppler shift for the light. Let us say here is the imaginary observer. The wavelength, which is the frequency which is observed by this imaginary observer, will be, let's say, f prime. Say f prime is equals to f naught and the square root of 1 plus v over c over 1 minus v over c. When the observer moves towards the source or source moves towards the observer, we will apply this formula. But in this case, the source is moving away from the observer, so v will be replaced by minus v. So the frequency observed by this imaginary observer will be f prime is equals to f naught the square root of c minus v over c plus v, because v is minus v here. Now what will be the frequency which is received by this moving observer? Well, this reflected light will behave like the secondary source. The wavelength, the light is moving now towards the observer, but the observer is moving away from the source, so we can apply the formula once again. So let's say the frequency received by the observer is f, so f will be equals to, the frequency here is f prime, so it will be f prime square root of 1. Once again, and the observer is moving away from the source, so we will use minus v here, so 1 minus v over c over 1 plus v over c, which is equals to f prime c minus v over c plus v. So putting the value of f prime, what we will get, f is equals to f naught c minus v over c plus v. If lambda prime is the wavelength observed by the observer, so we can put f is equals to c by lambda prime, and it was c over lambda c minus v over c plus v. So c and c will cancel out, so lambda prime will be equals to lambda c plus v over c minus v. Hopefully this should be the correct answer. So we got 4. Thank you.